the current thinking, including particle physics, must be reconfigured because it's wrong. If photons have mass and particle theory uses massless particles, well, then something is wrong and it needs to be reconfigured. So what do I put down here? Yeah, I'll go back to that later. So if we know that light will bend in a gravitational mass, right? A large mass, gravity, light will bend. And it needs nothing to do, this is what Newton understood, maybe even before that. But if it bends like that, then it has to be true that the photon has mass. Because of Newton's third law of motion, if the mass, whatever it is has a force acting upon the light, then the light, even their photons, have to have mass to act on the other mass. So that's what keeps it bending. If it had no mass, it wouldn't bend. It would just keep going in a straight line. Photons have mass. Right? I'll say it there and I'll say it loud. Photons have mass. Okay. So that's another thing. You can go look at it. I explain what's going on. Okay. 4. Light in transit, or LIT, and Einstein's cross. Scientists see Einstein's cross as an example of gravitational lensing. First, let's understand that there is no lens because the bending comes from the force of the gravitational field. But what the observer sees as 4, 5, and if one counts the center, if you look at Hutra's lens, I mean the galaxy before supposedly it blocking the quasar behind it, if you look at it, there's also like a little light similar to the other 4, only it's in the center, so that's 5, right? Yeah, blah, blah. Lights, okay, where was I? But what the observer sees as 4 light objects lensed from a supposed background quasar, which I say isn't there, is nothing of the kind. This would be physically impossible to see because of light in transit, which is the light that passes observers all the time but is never directly seen. From this it is understood that the 4 objects are not from gravitational lensing, but are 4 independent real objects. Right? That's what it is. They're 4 actual real objects. Has nothing to do with gravitational lensing because you just never see it. If you go to my video and look at it, I explain it in detail what's going on for light in transit, right? I mean, one thing, if you look up in the sky, let's say even at night with light, you don't see white light just passing all over the place. Someone had said it before, and I agree, that if you could have it dark enough and you had the stars up in the sky, it would be white, right? Because there's just billions and gazillions and billions of stars. And so you'd look up at it and it would look all white, right? Even though if you look perpendicular, in other words, if you look perpendicular, you might see light coming through it, but you actually don't see it. If you look up at the object, you'll see it coming. If you look at the object that it hits, you'll see it. But if you look perpendicular to the line of the light ray, you don't see it. And that's what light in transit is, right? It passes by, but you don't see it. Okay, so that takes care of 4. 5, the behavior of photons in the visible light spectrum. So the first basic idea introduced in this video is that visible light travels in a straight path, not in waves, in accordance with Newton's first law of motion. This view is explained in detail. In other words, I'm just looking at visible light, but I'm saying visible light does not travel in a wave form. It wouldn't make any sense why it would do that. You know, we got caught up in it. I'll explain it with Thomas Young, but visible light, I haven't inspected anywhere else. I haven't gone higher frequencies or lower frequencies. All I looked at was visible light, right? So I know that. If somebody wants a master's thesis or somebody wants a dissertation, go look at a different range and see if that's true as well. Okay, the second idea is that Thomas Young's 1801 double-slit experiment was very much flawed. What he represented in his original drawing was based on water waves and not light waves. If you look at his original drawing, you know that's not possible. You can't see light waves like that. Yeah, one could never have seen such detail with individual light waves, okay, even though they don't exist, too. Conclusion, the wave-particle duality of visible light does not exist, as light only travels in a straight line, right, unless it's bent by gravity. The supposed interference patterns are in truth simply probability densities. So what you see on the background as light goes through, it isn't interference patterns. That happens in water, but it doesn't happen with light, right? So what you're seeing there aren't interference patterns, they're actually probability densities that take on the appearance of interference patterns, because Thomas Young was using water, to explain it, and water behaves differently than light, so you can't have that. Water, interference patterns. Light, probability densities. That's the way it works. Okay, several other ideas about the properties of light are also explained and demonstrated. Okay. Questionable realities, gravitational lensing, and gravitational waves. This video brings into focus whether the many lensed objects classified as such are truly images or real objects that have been misclassified, like Einstein's cross. One has to remember this is not actual lensing, but a bending of light near a large cosmic mass. As I mentioned in the video, if it's gravitational lensing, then it's not real. If it's real, then it's not gravitational lensing. I demonstrate this with some examples, right? So people are seeing gravitational lensing all over the place, and I'm going, well, I mean, it's possible, but some of what they're seeing might not be gravitational lensing. It actually might be real objects, and it's not caused by a quasar in the background, right? They're just real objects like Einstein's cross. Okay. The second part of this video discusses the problem with gravitational waves. There are three basic problems. Gravitational waves are built upon gravitons. They have never been detected, right? You have gravitational waves, and they're based on gravitons. I understand the problems inherent in that, but at the same time, you can't throw them out there and say they're gravity waves if you have no idea whether the basis for their existence even exists. So that's one major problem. I actually wrote this to Kip Thorne and Barry Barish and Rainer Weiss. They all know about it, they just ignored it, so I'm used to that. 2, gravitational waves ripple through curved space-time. Here one must define the material reality of the composition of space-time. This will never happen because space-time doesn't exist, right? So space-time doesn't exist. You have to define what space-time is, and nobody can define it, and so it doesn't happen. I mean, it might be wishful thinking that gravitational waves filter through, ripple through space, but if you can't define it, then there's nothing there. I mean, that's basic science. There's nothing there, right? In fact, I do in the, I said, it is true that Newton never defined gravity, but Newton never stated that space bends, warps, or curves. And as far as the idea of time, see the video title, The Time is Up for Space-Time, number 9. Right? So there is no time. If you can't bend space and you can't bend time, then you can't bend space-time, and space-time doesn't exist, either in Minkowski's flat space-time or Mr. Einstein's curved space-time. And I get into that, right? Okay. The third one is how can the 2.5 mile tubes of the interferometer, this is the LIGO project, right? The Laser Interferometer Gravitational Wave Observatory. They also won a Nobel Prize for this. I question why. But anyway, tubes of the, how can the 2.5 mile tubes of the interferometer be filled with space-time when space-time can't even be defined? How do you know there's space-time in the tubes if you can't define what space-time is? How would you know it? You wouldn't, right? All the LIGO project had were huge vacuum tubes, and space cannot be displaced or compressed. They have bupkis. In other words, what they had was a huge vacuum tube, 2.5 miles long, I think 4 feet in diameter, and mirrors with lights and lasers and stuff. But you can't displace space, you can't compress space. So how could the mirrors move if it's a physical impossibility? Oh well, let's pretend the problems don't exist. That's a good way to do science. Lastly, I speak on the problems I see in the physical sciences: physics, astrophysics, astronomy, and cosmology. As much as I admire Mr. Einstein as both a scientist and a humanist, he is being given credit for way too many scientific findings at the expense of other scientists. One, in fact, is actually finding the correction for the for mercury. I'm going to botch it, so I'm not going to say it. Finding the I don't know. I'd have to get back to that. But the correction for the perihelion of mercury, and a lot of credit is given to Mr. Einstein, but in fact it was a German mathematician, I think a high school teacher, that actually found the correct formula first. But of course, I mentioned it in the article, or in the video that I do. I haven't done it for a while, so I'm sort of forgetting my names, but they don't give him any credit for that. Everybody's putting the discovery of the correction of the perihelion of mercury on Mr. Einstein, when in fact it's someone else came up with the actual formula first, and it was the correct formula. So he didn't copy from anybody, right? He has the correct formula. So if I think of it before the end of my video here, then I will say it. And I'm trying to think of it, and I can't think of the mad person's name. Okay, 7, the velocity addition equation. A tale of two theories and a timeout. Okay. The velocity addition equation is introduced. Unfortunately, there are several problems with it. The velocity addition equation does exactly what it was designed to do by entering two variables, velocities. The velocity addition equation will always render a velocity that was less than the speed of light. Right. Because it was designed to do that. Right.